Okay, welcome to the Unit 2 review. Now let's start off here with objective number 1, where we are interpreting parts of a quadratic expression such as terms, factors, and coefficients. Okay, so these questions are a little bit different than what you normally see in your homework. They're testing you, however, on your understanding of vocabulary words, which we've gone over recently. First of all, on number 1, I have to admit that we had a mistake here that we put. We had a k squared and then a 13x. It's obviously supposed to be the same letter. Well, it's not obvious because, later on we've got mixtures of different letters. So hopefully that wasn't too confusing to you. But we have this expression, and let's just call it x squared minus 13x plus 42. And we're supposed to identify the number of terms, the leading coefficient, and then factor it. Okay, so the skill that we're using here is factoring, which we have done quite a bit of. The two parts that you need to know vocabulary for is number of terms. Okay, first thing, we have 3 numbers of terms. This is the first one. Let's see, let's make this a little bit bigger so we can work with this, okay? This is the first one right here. This is the second term, and this is the third term. They're all connected by addition, or subtraction. Subtraction is just another type of addition. So all these 3 terms are connected. So the number of terms is 3. Okay? The leading coefficient, okay, is where we go to the first term and we find its coefficient. Okay, the coefficient is the number in front of the variable. Like, for example, over here on the second term, it's negative 13. But the coefficient on the first one, since we don't see it, is a 1. Okay. Now we'll put this in factored form. X squared minus 13x plus 42. We have a value that's just 1s, so we really don't need to worry too much about it. We're just looking for 2 factors of 42 that are going to add up to negative 13. Okay? And 42 is 6 times 7. So we got a 6 and I got a 7. They add up to 13. If both of them are negative, they will multiply to a positive 42 and add to a negative 13. So these are my 2 factors. The first one would be x minus 6, and the second one is this one right here, x minus 7. So that is now in factored form. Okay. Going to number 2, we also have 3 terms. We have a leading coefficient that is 7. And now as we go into factored form, I know 7 is only going to be made up of a 1 and a 7. Now, 245, that's kind of big. Well, probably the first thing I want to see is if 7 goes into 245, because then that's going to allow me to make this smaller. And now as I look at it, I see that it will. So remember, when I'm factoring, I'm dividing. So the first thing I need to do is see if something divides all things, and 7 does. 7 will make that x squared plus 2x minus 37. Okay? Is that right? 7 goes into 24 3 times, 3 left over. Oh, 5, 35. 35. Okay, so now I'm looking for just 2 numbers that multiply to make negative 35 and add to make 2. One will be positive, one will be negative. Okay, 35 is 7 times 5, so we get a 7 and a 5, and obviously one of them needs to be negative. The 5 does because it's a positive 2. So my 2 factors are going to be, well, I don't have 2 factors, I have 3. I have the 7, okay, the 7, then I have the x plus 7, and the x minus 5, okay. All right, let's move on to objective 2. Okay. Objective 2 is to use the structure of an expression to identify ways to rewrite it, and basically that's just talking about factoring. Okay, so number 3 and number 4 are problems that students struggle with a lot. And the more experience you get, the easier these ones are. But when you're still inexperienced factoring, they sometimes throw you off. Okay, take a look here at number 3. This expression right here only has 2 terms. It does not have an x term in the middle, which would be called our b term. So what that term actually is b equals 0. Okay, so I'm looking for the 2 factors of 9 and the 2 factors of 121. They're going to come together to make 0. So when you make 0 with adding, what you're doing is you're finding opposites, right? So notice that 9 is a perfect square. So 3 and 3 will be the same numbers, okay? And then 121 is 11 times 11. So I will get 33 and 33. When I multiply those together, they're the same. One of them will be negative, so that it turns it into 0. This pattern is called the difference of 2 squares, where, once you recognize that pattern, you begin to notice what the factors are. But even so, it's just as quickly to discover them this way, where, you're just trying to make 0 out of things, and so you're going to have things that are the same, and one positive and one negative. So my 2 factors here would be 3x plus 11 and 3x minus 11. Noticing that 3x is 9x squared, the square root of that, and 11 is the square root of 121. Okay. All right. This one kind of threw people off a little bit as we were working. A lot of students asked about this one. Remember, we are factoring, we are dividing. So the first thing you want to do is you want to look and see if something divides all the terms. And that includes the variable. That includes the a in this situation. Okay? And some people may not have noticed that 7 goes into 91 because it's a number sense thing that you don't see every day. But it's something you might want to double check. 7 is a prime number. If anything goes into 7 and something else, it's going to be 7. And 7 does go into 91. So if I take a 7 out and an a out, and when I say take it out, what I mean is divide it. I'm writing this as I'm dividing and writing it as 2 things multiplied by each other. That's what factored form means. Okay. If I take 7a and I divide it by 7a squared, I'll be left with an a. And when I divide 7a by 91a, I'll be left with 13. And so that is my factored form right there. Okay? These other questions right here might confuse people just in their format. But, number 5 is really just asking you to factor this. Okay, notice that this is equal to some factored form of this. So when you factor it, you'll notice that we talked about this a term comes from the multiplication of the first and second terms. This c term comes from the multiplication of the last 2 terms. So basically, all you're figuring out here is what value of k is going to make this statement true. What times 4 will equal negative 28? And so the answer to that is that k equals negative 7. Okay? Now notice that in the number 5, we take the standard form and we go to factored form. In number 6, we're taking the factored form right here and going to standard form. So we're not factoring, we're basically multiplying. So if I take these two terms, 9x plus 5 and negative 3x minus 4, and I multiply them, I get negative 27x squared minus 36x. I'm distributing here, so if you don't know where that 36x comes from, that's the 9x times the negative 4 over here. Okay, then I'm going to distribute the 5 and get negative 15x and negative 20. So simplified, that becomes negative 27x squared and minus 51x minus 20. And I look over at this and see what in this ax squared plus kx plus n, what is the a? Okay, well the a is obviously negative 27 now. So I'm going to write negative 27. What is the k? The k is negative 51. Put that right there. Okay? And if they asked you for what the n was, the n would be negative 20. They might ask you on the next page. I can't remember. Okay? All right, let's move to the next page. Yep, there's the n. So that's where we put the negative 20 right there. Okay. So again, we're factoring. And when we factor to identify solutions, we're setting the equation equal to 0, because when you multiply something by 0, it equals 0. So the way to get to our two solutions is to factor it into spots. So I'll have 12. Here, let me make this a little bit bigger for each question. So, all right. So we get 12x squared plus 7x minus 10 to set this equal to 0, because I'm just subtracting this 10. So it's just going to be addition and subtraction to move terms around when they are connected by addition. Okay, now we've got a 7x term here in the middle, so there's nothing that's going to divide. 7 doesn't go into 12, 7 doesn't go into 10, so I have to start using and trying to figure out what is going to add up to 7 that is multiplied from the factors of 12 times the factors of 10. I'm just going to start, I do not know the answer to this question right now. I'm going to start with 3 and 4 for 12, okay? Because I know that this number is going to be small, or that the 7 is kind of a small number, and sometimes I forget you can't see where I'm pointing when I'm doing this. And I know that negative 10, one will be positive, one will be negative. So I'm trying to keep this difference of these two numbers at 7. So I was going to say let's multiply 3 times 5. Oh, that's going to work. And let's multiply 4 times 2. And so I'll get 15 when I multiply 3 times 5, and 4 times 2 I will get 8. And that's going to give me a difference of 7, knowing that the 8 has to be negative. So I'll make that 2 negative. And I will get the factors 3x minus 2 and 4x plus 5. I kind of almost wish that I got the wrong answer first, or the wrong combination first. I could show you. Maybe I'll do that on the next problem. So now this could equal 0, or this could equal 0. And so if I add 2 and divide by 3, I would find that x could equal 2 over 3 if I make this thing equal to 0. And I could get subtract 5 and divide by 4, so negative 5 over 4 could be the other answer to that. Okay. All right, number 8 is already set equal to 0. and we have 19, which is a prime number. Okay. So we've got to start taking the factors of 10. Let's just take 2 and 5, just for giggles. We've got to make a 19, so we need to multiply. I don't want to get too big. Let's just try 6 and 1. Hopefully, yeah, that's not going to work, which is great. This is exactly what I'm wanting to have. This is not going to work. 2 times 6 is 12. 5 times 1 is 5. And together those add up to 17, right? So I need to make this number bigger. And I make numbers bigger by widening the difference between the two. So I need to make a number bigger than 12. But 17 is not that much smaller than 19, so I don't want to go that much bigger than 12. I got to think of something that's a factor of 10 with something that's a factor of 6 and try to make a number bigger than 12. Okay? Right now I'm thinking 15. All right, so I can take 5 times 3 and make a 15. So let me just go. That's 5 and 2 would be the factors to make 10. And then 3 and 2 would make 6. So 5 times 3 is 15, and 2 times 2 is 4. And so I get 15 and 4, and yes, those do make 19. So that's the magic combination there. So my factors would be 5x plus 2 and 2x plus 3, and that's equals 0. So x could equal minus 2 divided by 5, negative 2/5, or minus 3 divided by 2, negative 3/2. Would be my answers. Okay. That's always fun to do. Okay, let's move to objective 3, where we have word problems. I'm going to have to kind of shrink this and then bring it back out a little bit so we can read the problem. These are things that I'm a little concerned with some of us. We've got to be invested. If you're not invested, you're probably not watching this video. But you gotta put yourself in there and not just shy away from the problem because it's got words in it. Okay? Basically, this is the same thing that we are doing with any kind of quadratic equation. We are solving the equation, and we have to figure out what the equation is from reading the story. Okay? So it helps kind of visualize what's going on here. A signal flare is fired into the air from a boat. The height h of the flare in feet after t seconds is h equals negative 16t plus 160t. The first thing that you need to notice is that h is the height of the flare, that t is the number of seconds. And so those are the things that you need to think about. There are two variables, and in order to know what one of them is, you have to be able to plug something in for the other. And so when you're asked to find how many seconds something is, like when will the flare hit the water, then you have to be given the h. You're going to be asked to find t, so you're going to have to be given the height in the sentence. Now, it's not totally spelled out for you right here. You have to use your noggin, which is what school is all about. When will the flare hit the water? So you got to think, what is the height when it hits the water? Okay, so hitting the water is a height of 0 because the water is on the surface. So we would write this equation as negative 16t squared plus 160t, and we would set it equal to 0. Now, you could use a quadratic formula from here, which I think would be the least efficient way of doing this. Because what I notice when I look at this is here's a 16 and here's a 16 as part of 160. That I probably can factor this out. They both have t's as well. So if I factor this, I get negative 16t t times t minus 10 equaling 0. And I would get times of 0 and 10 for the seconds. Okay? And so really what I begin to realize here is that the height of the flare has started at the water, and it's ending after 10 seconds back on the water again. Okay? So the second question is how high the ground when the flare was shot off. And again, when the flare was shot off, how many seconds had elapsed? And the answer to that is 0, because it's right when the flare is shot off. This equation's not being, it doesn't describe what's happening before the flare was shot off. So when the flare is shot off, that's 0 seconds. So if I want to say the height is equal to negative 16 times 0 squared plus 160 times 0, okay, I would see that the height is actually 0 at this point. And it may not be on the question on the test. You know, you might have some value on the test in the equation, like written out here, like plus 5. Like if it had been written as like the flare was shot off from 5 feet off the ground, then it would have a plus 5 at the end, and you would say the height equals 5. But that's not the case in this question. So, all right, let's move on to number 10. Since it's a video and you can't ask questions during it, if you do have questions, please feel free to comment. Okay, number 10, a rectangle has a length of 2x plus 1 and a width of 2x minus 1. Okay, sometimes it's helpful to draw. Okay, so this would be the 2x plus 1 side since it's longer, and this would be the 2x minus 1 side. Okay, and so we're going to write an expression that represents the area. We know that length times width equals area. So we would say that that's 2x minus 1 times 2x plus 1. That equals the area. Okay, you multiply that together. I will accept this answer right here as the expression. However, you'll have to do more to solve it, so you might as well go ahead and multiply it out and say that that's 4x squared minus 1. After you multiply it out, that's what you'd figure out what it is, equals the area. Okay. So for what values of x is the area equal to 15? Well, let's just plug in 15 for the area and say, well, that's 4x squared minus 1 equals 15. We add 1 to both sides. Now, why am I adding 1 to both sides? Because I don't need to use the quadratic formula or factoring here, because I only have one x squared term. So if I add 1, divide by 4, and then square root, I should be able to get my answer. 15 plus 1 is 16. Divided by 4 is 4. Square rooted is, and this is a key, which we learned in quadratic formula, is plus or minus when you square root something. Plus or minus square root of 4 is plus 2 and minus 2. So those are the two values that you get. Do all of your solutions create a reasonable length and height? Well, no. If I plug in negative 2 into this equation, right, or this expression right here, I get negative 5, which cannot be a width. So I would say that 2 is reasonable, but negative 2 is not. So I would say no. Negative 2 gives a negative length slash width. Okay. All right. Well, let's move on to page 3. All right. Quadratic formula. Now, we've been doing, now I'm going to read these instructions. And I want to make sure that you guys understand what's being said by the instructions. Okay? Solve by using the quadratic formula. List the exact answers and round to the nearest hundredth if necessary. Identify the number and type of solutions the quadratic has. So there's two parts to this. One is list the exact answers, which is what we've been doing. Okay? Rounding the answers to the nearest hundredth is using decimals. So we want to have exact answers and rounded answers if it needs them. And that's what we're talking about there is we're talking about irrational answers where we would use the decimals, okay, to give something that is a more understandable answer. Okay, so take a look at this first one here. We have to, when we do the quadratic formula, set things equal to 0. So the first thing I'm going to do is I'm going to subtract 23 from both sides and get that expression. Okay, now I want to identify my A, B, and C. 7 is A, 5 is B, negative 23 is C. And I'm going to go straight to the discriminant, okay, which is B squared minus 4AC. So it's 25 minus 4 times 7 times negative 23. Okay, I'm going to plug that into the calculator exactly the way that it looks, okay, and get 669 for my discriminant. I will double check in the calculator to make sure that that is not a perfect square. And it's not. So I am now going to write my two exact answers as the opposite of B plus the square root of the discriminant over 2A, which is going to be 14. Let me write it as 2A though, just because I wrote everything else as letters. And then the opposite of B minus the discriminant over 2A. And you'll have the quadratic formula, so there's no need to stress out too much about that. Opposite of B is negative 5. We're going to have plus the square root of 669. And we're going to put that over 14. The other answer, negative 5 minus the square root of 669 over 14. Okay. And then I'm going to go ahead and get those two decimals. What I like to do in the calculator is, and it's hard to show the calculator while I'm doing this, but just I'm hitting negative 5 plus square root 669. And then I'm going to hit enter. And then I'm going to divide by 14. And I'm going to round to the nearest hundredth, so that's going to be 1.49 for that. Okay, then I'll take negative 5 minus square root of 669, enter, then I will divide by 14, and I will get make sure that I did everything right there. Yep, negative 5 plus negative 5 minus, and we'll get negative 2.20. Okay. So when I look at these two solutions, there's two of them. Okay. And what type of solutions are they? Well, they have radicals in them and they're not imaginary, so we call that irrational. That's the type of solutions they have. Alright, let's fly through the other three of these, and hopefully they'll make some sense in context with the others. Okay. Alright, here we go. B squared minus 4AC in this case is going to be 100 minus 4 times 1 times 25. Oh, look, 4 times 25 is 100. I'm going to subtract it, so my discriminant equals 0. So I'm going to have the opposite of b, which is actually going to be a positive 10, plus the square root of 0 over 2. And I'm going to have the opposite of b minus the square root of 10, which is 0 over 2. So basically what I got is I got 5, and I've got negative 5. Okay? Or not negative, jeez. Whoops. Time out. 5 and 5, right? Because when I add 0 and I subtract 0, I'm going to get the exact same thing. So x equals 5. The number of solutions is 1, which will only happen if your discriminant equals 0. That's the only time your number of solutions will be 1. Every other time will be 0. Okay? So the type of solution here is rational because it is a number that could be written as a fraction, but more importantly, you're just looking to see that there are no square roots at all or no imaginary, so that's a rational number. Okay? All right. Discriminant here, 25 minus 4 times 1 times 11. Let's check it out in the calculator. That's going to be negative 19. Okay? And so I'm going to get 5 plus the square root of negative 19 over 2, and 5 minus the square root of negative 19 over 2. Now that is an imaginary answer because we have a negative in our square root. So my final answer here will be 5 plus I times the square root of 19 over 2, and 5 minus I times the square root of 19 over 2. Okay? Those are two solutions, and they are imaginary. No need to write them as decimals. Okay? All right. Now, this one right here, we do not necessarily need the quadratic formula, but the instructions say use the quadratic formula. So you gotta follow instructions, right? Otherwise, you might end up in the clink at some point in time in your life. So we're going to take b squared, which is 0 in this case. B is 0. Minus 4ac. Okay, those are positive, so I'm subtracting. So I'm going to get negative 48 for my discriminant. Okay, so I get 0 plus the square root of negative 48 over 2, and 0 minus the square root of negative 48 over 2. And those are imaginary as well. So I am going to get, now I could reduce this. I'm going to go ahead and reduce this because I know that some of you will want to do that, and it's the best answer. So 48 is made out of 16 and a 3. Okay, four twos and a 3. So 16 is a perfect square, which I could take out. So that'd be like 4 times square root of 3. And I've got negative 4 times square root of 3. Actually, these are i's, right, because I'm taking out the imaginary unit. And those can be divided by 2. So my final best answer would be 2, well, let me write it closer to the line because it's not actually going to look like a fraction. 2i square roots of 3 and negative 2i square roots of 3. That's two solutions, and they are imaginary. Okay. All right, down the home stretch, going to the last page. Complex numbers. All right. First thing that we're going to do with complex numbers is we're going to add and subtract. Notice there's only one question about adding and subtracting on your review, which means there's only going to be one question on adding and subtracting in the test. So, like terms, we collect real numbers, which we have a negative 3, a negative 4, and that's it. We have a subtraction here. Okay, so some of you might want to just write these all as individual terms first. Okay, and I'll do that just because I'm here to help people who need help with this. So I'm going to distribute the negative because it's going to everything in there. So it's going to be plus 4 and minus 2i, and then a minus 5i. Now I can collect like terms. Negative 3, positive 4. My real part's going to be 1. Okay. My imaginaries, I got 1, minus 2, minus 5. So that's going to be a minus 6i. And that's my answer. Okay. All right, let's move on to 16. We are foiling, okay, which means we're distributing. Not a big fan of FOIL, but people know it. So negative 24 and negative 4i is me distributing the negative 4. And then negative 6i and negative I squared is me distributing the I. Okay. Now, the thing you want to do is understand that I squared equals negative 1. So this is negative of negative 1. So it means it's actually a plus 1. I'm going to add that to my negative 24. So that would be negative, I wrote a 3, meant to write a 2. 23, and then minus 10i when I'm combining the other like terms there. Okay? All right. 17 is just like 16, but you have to have the patience to write it out as what it means instead of trying to square everything in there. Go ahead and just write it out and distribute. 9 minus 12i minus 12i and positive 16i squared, which means negative 16. 9 minus 16, that's going to be negative 7, and negative 24i is my imaginary part. Okay. All right, same thing here with 5i cubed. Okay, I mean, there's a couple ways of looking at it. That you can say that's 5 cubed and I cubed. That's one way of looking at it. Or you can, if that's confusing to you, just go 5i times 5i times 5i. Okay, multiply all our 5s, we get 125. If you multiply this I times this I, you'll get negative 1. And then you still have the I left over. So what we have is a negative 125 times I. Okay. And part of understanding 18 kind of leads into what we're doing with 19. Okay. I really haven't talked too much about this in my class. But if we think about it, I equals the square root of negative 1. I squared equals negative 1. I to the third power is going to equal negative I, which is the negative square root of 1, and I to the fourth power equals 1. And then as we continue to go through there, because so we're taking I, and then I times I, and then I times I times I. We're taking the result and we're multiplying it by I. Okay? So it goes in cycles of 4, right? So if I take I to the 22nd power, that is I to the fourth power, let's see, 5 times, and then you are multiplying by I squared, right? So I to the fourth power equals 1, and so I have 2 i's left over, so I squared equals negative 1, so I to the 22nd power equals negative 1. Okay. Hope you enjoyed the video, and good luck studying.